We'll proceed in vector and commercial calculus, calculating the surface area. So we are in a kind of a war kind of situation where can we really calculate the surface area? Surface area in three dimensions. Oh, I'm sorry, surface area vector. There are two things in surface area. Okay, there are two things in surface area. So one is called surface area and one is called surface area vector. So if I have this ball, then hup, 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 if I have this ball and this is xy plane, there is a ball three dimensional, there is a xy plane. How I can do some kind of introspection into it? Okay, this is xy plane and this is origin. Now we have different set of x and y on the xy plane. If I take xy plane, if I take different point on xy plane, consider there is a point here called x comma y and I have a function over x comma y. What is your function over x comma y? My function is the square root of a square minus x square minus y square. If you place any value of x and y, it will result in one numeric value. Okay, function is the square root of a square minus x square minus y square. If someone set x equal to something and y equal to something, then it will result into some numeric value. It will result into some numeric value. It can be plus or minus. Minus plus, because it is square root, minus plus some numeric value. Now register the numeric value. Consider that numeric value is, if it is plus, then it is above this plane. If it is minus, it is below this plane. Now make a point here. I took some point x comma y and then whatever came through square root of a square minus x square minus y square. Now take this point. Consider that is z. Here minus z. Okay. Now take all the x comma y and take all the point. Okay, if you take it and draw here also bottom because it is plus and minus, right? Now combine all the point, it will become a skeleton of points. Okay, if you cover it, it becomes a surface. That is the surface that is centered at the origin and top is top hemisphere and bottom is bottom hemisphere of a circle. Okay, that of a sphere. So sphere that is half is above the xy plane and a sphere half is below xy plane, and that is a kind of equation square root of a square minus x square minus y square. That is z. Okay, that is not a surface. You are calculating simple z, right? This is what people don't understand. The biggest problem in mathematics is right now it is confined into book and equations only. People that never understand what is the real life scenario of the mathematics. So if I, what is the equation of this ball? If this ball is centered at the origin, if that blue color is the origin, blue color is the origin. This is center. The center of this ball is at origin. It is midway. It is not top of the xy plane. It is half, half. Half is up, half is down of this ball. Now, what is the equation of the surface of the ball? That is z equal to square root of a square minus x square minus y square. That is z. Z means z axis. Tell me surface of the ball. This is the surface of the ball. How you say this is simple z, right? X, this is x axis, this is y axis, this is z axis. Okay, in that sense, you're merely talking about z value. I'm talking about surface area. Okay, this is surface area formula. Z equal to square root of a square minus x square minus y square. How come you can say like that? If I take x and y some value, z will come to one value. Now consider if z comes to some value here, height, whatever the value comes, square root of a square minus x square minus y square, that value, consider it is the height. Now that is the z. Now this point is x comma y comma z. Similarly, take another x comma y comma. There is a set of point you will get like this. This is set of point, not the surface. Consider x and y, you take infinite in number, not 100 number, 1000 number, infinite in number. Now all the points, they will be continuous. They will come as continuous. There is nothing continuous in the world. Okay, people think that everything is continuous. Continuous world is different. Digital world is different. The digital world is where you don't take in continuous fashion, you take in discrete manner, one layer, next layer. In between, you don't define anything. If something is, there is an algorithm comes into the picture, which will decide if something is going below, beyond the one layer, then it will be confined into same layer or it will go to the next layer. That is digital world. There is the analogous world where everything is smoothly going up. There is nothing smooth. Everything is digital. I won't say more than that. Otherwise, if it comes to humanity, if it comes to nature, then people will go into different world. That whatever I'm seeing, bird is chirping, is the sound is digital, not analogous. What I was thinking. So okay, whatever it is. Anyway, now consider here x and y are infinite in number. X and y are infinite in number. Then all the point I'm thinking x comma y comma z in the space all are continuous and it will form a surface like this. What is the formula of the spherical surface? Z equal to or fxy equal to square root of a square minus x square minus y square. What is the formula of surface area vector? That is very tedious. Surface area vector. What is the formula of surface area vector? If this is centered at the origin, from the center of this ball, from the origin, center of this ball, take any point P here. That point is x comma y comma z. From center, now draw a line like this. This is called position vector. Any vector that passes through origin is called position vector. Now it is xi plus yj plus zk, position vector. If you differentiate the position vector, it becomes surface area vector. If you differentiate a position vector, it becomes a displacement vector. This is what we have shown. If it is two dimensions, there is a line curve, not the surface. There is a line curve. Here there is a surface. Here there is a line curve. It is centered at the origin. If there is a point P here, from origin, if I draw a point P vector here, d of P, differentiation of the P will be displacement vector. That will be along the displacement. This is the vector that is tangential at each point. Similarly, if there is a center of it, from center, if there is a point P, if I draw a position vector and differentiate it, it will become a surface area vector. Surface area vector is not along the surface. The way line curve vector is along the curve, surface area vector is not along the curve because it is not unique. Any point, if I take surface area vector, then if I move this surface area vector, any displacement vector or area vector, if I talk, then it points toward the tangent vector. If I any point P is there, and if I take tangent vector here, but tangent vector is not unique. All 360-degree, whatever the vector I am seeing, all are participants into the tangent vector. It is not unique. Then what the way I am rotating it, the way if I rotate it very quickly, it will look like a surface that is called tangent surface. It will look like a surface that will be called tangent surface. Okay, it will look like a surface, but that will be a tangent surface. Now on this surface, the tangent vector will be infinite in number in 360 degree. So the surface area vector is called, if I any point P, if I have a tangent surface, the vector that is perpendicular to the surface is called surface area vector. That is everywhere it is same. Okay, surface area vector. If I say line curve vector, the line curve vector is not perpendicular at the line. It is along the line. That is called line vector or displacement vector. But surface area vector, if there is an area like this, and surface area vector is perpendicular to it. It is in direction of the position vector. Someone can say like that. It is in direction of the position vector. But if it is if it is a sphere, if it is not a sphere, the curve is something different, then position vector is different and surface area vector is different. I believe it is understandable. Like consider that this is a surface. Now I'm not talking about the curve. This is a surface. See, this is a surface. Consider it is a surface. If it is a surface and this is the or if this is the origin, if this is the surface, if this is the surface, this is the origin, and this is the position vector I am taking. The position vector is in this direction, where a tangential vector at this point in this direction. If I say that my surface area vector is perpendicular to the tangent, then it will go in this direction, whereas position vector is going in this direction. Not necessarily that position vector and surface area vector, they will be in same direction. Position vector, if I have a position vector, differentiation of position vector will be the tangent vector. Okay, and perpendicular to the tangent vector plane, if I draw all the tangent vector at this point in 360 degree, that will be the surface area vector. Okay, someone is free to calculate the relationship between the position vector and surface area vector. Okay, so that is not a problem. Someone can try. If it comes in same direction, then it is all right. If it does not come in same direction, it is all right, because we are not meaning it will come in same direction. For a sphere, it will come in same direction. Now we are in phase of calculating the area vector. Area vector is d of position vector. Now we understood it. D of position vector, D of position vector, D of P, D of position vector is same as dP by dxy plane cross D into dxy plane. dP by dxy plane into dxy plane. D position vector by dxy plane. D position vector by dxy plane. And it resolves into dP by dx cross dP by dy. We have seen it. dP by dx, dP by dx means if I take any point P and we calculate dP, if we calculate the differentiation of position vector, then position vector that it results into new vector, and that vector can be anything that is tangent here. In that one tangent I take that is falls in xy plane, then I keep rotating, keep rotating, take another vector snapshot that falls in YZ plane. This is X axis, this is Y axis, this is Z axis. This is XY plane, this is YZ plane, this is XY plane, this is XZ plane, this is YZ plane, this is XY plane. Now, if you differentiate position vector at any point P, position vector is a vector that is from center of this point P. If I connect a line, that is position vector. Now, if I do D of P, differentiation of position vector, it will result into the tangent vector. The tangent vector is any one, all are tangent. Now, keep rotating it till it comes to a position where it falls in YZ plane. Keep rotating it, it falls in a position where it is in XZ plane. So that is one is dP by dy and one is dP by dx. If you take cross product of dP by dy and dP by dx, it will give you the area vector there. And whatever the area vector, new vector comes in, that is the area vector. dP by dx cross dP by dy or dP by dxy plane, same thing, into dxy plane, that is dx dy. dP by dx cross dP by dy into dx dy, this is full form of area vector. Now, we were in phase of calculation. If someone solves it, position vector is xi plus yj plus zk. Now, xi plus yj plus zk, that will come as dp by dx cross dp by dy will come as minus dz by dxi minus dz by dyj plus k whole multiplied with dx dy. This is the area vector. Anyway, now we were in a phase to do this area vector calculation in a spherical coordinate system. In a spherical coordinate system, same. What is position vector? Now, in a spherical coordinate system, I will not go purely into a spherical coordinate system. What we saw in a spherical coordinate system, a spherical coordinate system, the coordinate system, it has three components. One is called phi angle, one is called theta angle, and one is called radius. If this is a sphere, then from the center of this sphere, at any point, if I draw a line, this is called radius or radius vector. Okay, now from the center of the sphere, now this sphere is kept at the xy plane, not on the xy plane. It is centered at the xy plane. The center of this sphere coincides with the origin. On xy plane, there is a point called origin, 0, 0, 0. It is there. So half of this sphere is below the xy plane, half of the sphere is above the xy plane. If that is the case, if half of the plane is above the xy plane and half of the plane is below, half of the sphere is below xy plane. If that is the case, then on the xy plane, if I take radius vector and rotate the radius 360 degree, that angle is called theta. Or take the yz plane or xz plane. In that fashion, rotate the radius like this in pi degree, in pi 180, not 2 pi, 180. This angle is called phi angle from the vertical. Phi angle. This is one, phi angle is one component of a spherical coordinate system. Theta on xy plane, this rotation is called one theta, one component, and one is radius. There are three components in the spherical coordinate system. Theta phi, and r. Now we are trying to calculate area vector in a spherical coordinate system, hybrid, Cartesian plus spherical, not completely spherical. Completely spherical coordinate system is not available in any of the book. Go and try and see. Everywhere the transition is there. Transition is means hybrid, Cartesian and spherical. This is what we are talking now. That we will talk later. So if I talk the hybrid model, then I have d of position vector. D of position vector is same as d of position vector by. Since we are calculating the surface area vector, this surface area vector. Now, if I see three component here, then this radius is constant along all the surface. Full surface radius is constant. Radius is not varying. What is varying here is, if I take the surface, then this theta is varying. Theta, theta is demonstrated by the theta arc. If I rotate the radius in xy plane, it will make, see, it makes an arc. It makes an arc. That is called theta arc. That is actually the theta vector. This arc and this radius are perpendicular to each other. If radius rotates in xz plane, it forms another arc. That is phi arc. This arc and this radius is always perpendicular. This arc and this radius and horizontal arc, all three are perpendicular to each other. That's why it is a spherical coordinate system, because all three are orthogonal to each other. Now we are calculating the surface area vector for the sphere. Now here the varying thing is, if there is a surface area, if I take a small surface area, area means it has two sides. One side is the horizontal arc, another side is the vertical arc. Horizontal arc is theta into r. Vertical arc is phi into r. Okay. Now in that sense, now if I am trying to calculate the surface area vector is d of position vector, same as d of p divided by d theta phi into d theta phi. I can do whatever I say. If I divide something and multiply by the same thing, it's all right. So dp by d theta phi into d theta phi. If dp by dxy plane becomes dp by dx cross dp by dp by d theta phi will become dp by d theta cross dp by d phi. This proof is not there available in any of the book. Into d theta d phi. D theta d phi I can write as d theta phi plane. It becomes d theta d phi. Now d of position vector is the area vector that becomes d of p by d theta phi plane. That into d theta phi plane. Full becomes dp by d theta cross dp by d phi into d theta phi. d theta d phi. Okay, now position vector p is xi plus yj plus zk. X is r sine phi cos theta. Please watch previous video. Now x, if this is radius, then if this is phi, then r sine phi falls on xy plane. Cos theta, this is x axis. R sine phi sine theta, this is y axis. R cos phi, this is z axis. So xi plus yj plus zk becomes r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k by d theta cross r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k by d phi. If you settle it down, we did in very big manner last time. If you settled it down, this cross product, it becomes r square sine phi cos phi k, or sorry, if I quit k at the end, it becomes r sine square phi, r r sine square phi cos theta I plus r sine square phi sine theta j plus r square sine phi cos phi k. This is what it becomes. D phi, d theta, d phi. If I make it complete area vector, it becomes d theta, d phi into r square sine square phi cos theta I plus d theta, d phi, d theta, d phi r square sine square phi sine theta j plus d theta, d phi into r square sine phi cos phi k. This is the area vector in a spherical coordinate system. If this is the area vector, someone is free to calculate the flux. Flux is nothing but velocity vector multi dot product with the area vector. How much is the fluid that is passing through the area? If this is the fluid and this is the area it is passing through, how much is the volume that is coming out of this area? How much is the volume that is coming out of this area? Velocity multiplied by the area. If velocity in some other direction, then area vector, this is area vector perpendicular to the surface area. This is a velocity vector. Okay, if that is the scenario, then velocity vector dot area vector, that is the net flux, or velocity vector dot d of position vector of the area. That is also same thing. Anyway, through that only we got this area. Now we were saying that if there is an electric charge is kept at the center of this sphere, then electric field is coming out of it in omni way. And the formula of electric field is q r vector divided by r to the power 3. Now, how much is the electric field coming out of this surface? Consider the electric field is like a liquid. How much is liquid coming out of this surface? Velocity vector dot product with the area vector. Velocity vector is q into r vector divided by r to the power 3. Now here r vector is xi plus yj plus zk. Xi plus yj plus zk. That is r sine phi cos theta I plus r sine phi cos theta sine phi sine theta j plus r cos phi k divided by r square sine, I believe it will become a1, r square sine square phi cos square theta plus r square sine square phi sine square theta. That becomes r square sine square phi plus r square cos square phi. That will become completely r square to the power 3 by 2. It becomes r to the power 3. Same as radius only. But for surface area, this radius is fixed, that is r or a, whatever someone takes. Now I can take out q by r to the power 3, that is constant. Now here we have r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k dot product with the r square sine square phi cos theta I plus r square sine square phi sine theta j plus r square sine phi cos phi k d theta d phi, that is the area vector. Now someone please go ahead and calculate the dot product of these two vectors. Whatever comes r square, take it out as a constant. So it will come as r to the power 3. Anyway, divide by r to the power 3. R story is over. Our story is over. How it will become? First is sine phi cos theta. Sine phi cos theta dot product with sine square phi cos theta. Sine to the power 3 phi cos square phi. Next is sine phi sine theta. Other is sine square phi sine theta. It becomes sine to the power 3 phi sine square theta. If you settle down, it becomes sine to the power 3 theta. Sine to the power 3 phi. Sine to the power 3 phi. Now, last term is cos phi, and there it is sine phi cos phi. It becomes sine phi cos square phi. Now, here sine to the power 3 phi plus sine phi cos square phi. Sine phi, someone can take out sine square phi plus cos, that is also gone. Only sine phi. Oh, it was that easy. Only sine phi remains here. If sine, then now sine phi d theta d phi. Sine phi integration is minus cos phi. Phi is 0 to pi. Phi is 0 to pi. So cos phi 0 to pi becomes 1, 1, 2. It becomes 2. And d theta theta 2 pi, 4 pi. 4 pi q. Hope we got the solution. 4 pi q. So through the spherical coordinate system, we can also calculate it is 4 pi q. But certainly it is not a big gain where we were calculating everything through Cartesian coordinate system, where it was xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2 into q. That was the velocity vector dot product with minus dz by dx minus I minus dz by dy j plus k dx dy. I believe the complexity is same, but anyway, we will do it in different session purely into spherical coordinate system. But anyway, we are in phase of calculating area vector. And area vector, we calculated it. Sine square r square sine square phi cos theta I plus r square sine square phi sine theta j plus r square sine phi cos phi k d theta d phi. This is full area vector for the spherical coordinate system. How we find d of position vector is the area vector. D of p is nothing but d of p by d theta r plane into d theta r plane. That is dp by d theta cross dp by d phi. Sorry, d theta phi plane. dp by d theta phi plane into d theta phi plane. And it came like this. This is not there again in the book. How people calculate area vector in the book. Now take any small area section here. Now calculate the area vector and get the unit vector of it and calculate the physical area, multiply it. Area vector is nothing but area, magnitude of the area, dot product with the area unit vector. Same thing is area vector. What is area unit vector? Area unit vector anywhere it is like a spherical coordinate system. It is like a radial vector. It is like a radial vector. That is area vector. What is radial vector? Radial vector is xi plus yj plus zk. That is the radial vector. Because if I take any point x comma y comma z, from center if I draw a line, that is the radial vector. That is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. Now calculate the magnitude of it. That is r square sine square phi cos square theta plus r square sine square phi sine square theta plus r square cos square phi. Okay, whatever it comes, I believe it will come as r square r only. This is what I think so, whatever it is. Now calculate the unit vector along the area. Calculate the unit vector along the area. Now calculate the physical area. Physical area is one side it is theta r and on the other side it is theta r. and other side it is phi r. Consider this is r. Consider this is r. R sine phi cos theta, or r sine phi. R sine phi is the radius component on xy plane. That into theta is this r, and r phi is this r. So r sine phi d theta, and r d phi, r sine phi theta and r phi. That is, if I take d theta d phi, then r sine phi d theta, r sine phi d theta, cross product, cross, because we are calculating area, right? One is in this direction, r, that is r sine phi d theta. Direction, this direction is theta direction, whatever it is. Another is in this direction, r d phi. So r sine phi d theta cross r d phi. If you do this cross product, it will come in radius vector only. And anyway, we have unit vector as radius vector. So whatever it is, the area vector will resolve into r into r sine phi d theta r d phi. It will become r square, r square. R is a constant because we are calculating area vector, and area is surface area. So radius is constant. R square sine phi d theta d phi. Exactly, we calculated this same with the with the a kind of I'm sorry. Okay, so the unit vector, I'm sorry, we calculate the physical area. In a modern book, you find area vector, you calculate the physical area and then unit vector multiply with the unit vector. The unit vector we found is the area vector is actually the xi plus yj plus zk. If you calculate the unit vector, it becomes r unit vector 1. Okay, it becomes, if you calculate the magnitude of r sine theta, r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k, this is exact analogous to xi plus yj plus zk. That is the area vector. Area unit vector is xi plus yj plus zk divided by x squared plus y squared plus z squared to the power 1 by 2. That is the area unit vector. Multiplied by this area is the area vector. This area unit vector will come as 1 in the direction 1. Area unit vector will come as 1 in the direction of radius. Whereas as the area, the area will come as r sine phi, r sine phi, r sine phi d theta, cross product with the r d phi. If you calculate, it becomes r square sine phi, r square sine phi some vector. If you calculate the magnitude, it will remain at r sine square phi. So net area vector is r square sine phi along the radius direction. Okay, that is that r sine square r square sine phi d theta d phi area vector along the radius direction. Same thing we calculated with dp by d theta cross dp by d phi. Same thing we calculated. Okay, and same thing we got there also. Okay, someone can revisit what we have done. Okay, so that is the how we calculate the area vector. Can we calculate area vector of a cylinder? Okay, can we calculate area vector of a cylinder? Cylinder has area vector like this. Cylinder has base as cylinder has this base on xy plane. The cylinder is kept on xy plane. There is a cylinder that is kept on xy plane. If this is the surface area of the cylinder, or cylinder is kept on xy plane, it is hollow here. And if this is the surface area of the cylinder, this is area vector of the cylinder. What is the formula of area vector of the cylinder? Okay, let's go through our way. If there is a point P here, then D of P is the area vector. Now, D of P, what is variable here? If you take cylindrical coordinate system, this is kept at xy plane. And this is a circle for which there is a center and there is a radius here. This radius all along the surface is constant. What is varying is the theta and z. So now if I want to calculate surface area here, if I take any point P here from the center, if I draw this position vector is P. D of P, differentiation of P is the area vector. This is what we have seen. So D of P is same as D of P by D theta z plane into d theta z. This is our proof. This is not available in any of the book. Please mind supporting us. Plus 91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the country, is the India country code. Now d of p is same as d of p. D, small d and capital P on top of it a vector. D of position vector. That is dp by dp by d theta z plane into d theta z plane. That is the area vector. Area vector is d of p only. Now divide by d theta z plane, multiply by d theta z plane. Now in that case, how it will become? What is position vector? That is xi plus yj plus zk. X is r cos theta. X is r. If there is r can rotate like this only. R cannot go like this the way it was going in a sphere. Okay, in cylinder, r is in xy plane only. So if there is r like this, r cos theta is x, r sin theta is y. Z is independent of r and theta. Anyway, x is r cos theta I. So xi plus yj plus zk. dp by d theta z plane. dp by d theta cross dp by dz into d theta dz. Okay, that is the area vector. dp, d of r cos theta I plus r sin theta j plus zk, whatever is the height, by d theta. Now r minus sin theta I plus r cos theta j plus gone. Okay, cross product with the d of r cos theta I plus r sin theta j plus zk by dz, all gone, only k remained. Now do the cross product. If you do the cross product with I and k, it becomes I and k becomes minus j. Anyway, minus is there, it becomes plus. Plus j. Plus j is now r sin theta. R sin theta plus j. Similarly, second one if you do, then it becomes r cos theta I. So r cos theta I plus r sin theta j. R cos theta I plus r sin theta j d theta dz. This is the area vector. This is the area vector, isn't it? Are you kidding? Okay, what are you saying? I am saying r cos theta I plus r sin theta j into d theta dz as per our calculation. This is primitive calculus. This is the actual original calculus. Now someone can resettle it, or you can take out, it becomes cos theta I plus sin theta j into r d theta dz is the area vector of cylinder. No. I'll go with the modern calculus. What is modern calculus? Modern calculus is take any small strip out here, that is dA, where one side is the arc and another side is the height. They are so small. Now what is the arc length? That is radius d theta. What is the height? dz. Oh, I found the area. Area is r d theta dz through the along the r vector, whatever it is. But if you calculate the actual area, see there is only one vector is there. It will come as r d theta dz. Now I have to find the area unit vector. Multiply area unit vector with the magnitude of the area. It becomes area vector. What is the area unit vector? Area unit vector is all along, it is like radius only. That is xi plus yj plus zk. That is the area unit vector. Xi plus yj plus zk divided by x square plus y square plus z square square root. That is the unit vector along the radius. That is the area vector. Okay, this is hypothetical. What is area vector? That is like radius, because you see radius is this is. Anyway, this is available in the book. So what is now xi plus yj plus zk divided by x square plus y square plus z square square root? Now, if you take this, then what it will come? So xi plus yj plus zk. That is, I'm sorry. What is radius? Radius is only along the xy plane. There is no z in the radius. So zk is not there. Only xi plus yj plus xi plus yj divided by x square plus y square square root, because radius is only in xy plane. These are the problem with the modern technology. Anyway, r square cos square theta I plus r square sin square theta j divided by r square cos square, I'm sorry, r cos theta I plus r sin theta j divided by r square cos square theta plus r square sin square theta. So square root, that will become r cos theta I plus r sin theta j divided by r gone. Cos theta I plus sin theta j, this is the net area unit vector multiplied by the net area, that is the r d theta dz. So now it becomes area vector, that is cos theta I plus sin theta j r d theta dz. This is modern calculus and our is the old calculus. D of position vector gives the d area vector. D of position vector is same as dp by d theta z plane into d theta z plane. That is same as dp by d theta cross dp by dz into d theta dz. This way you can calculate any area, get position vector, and then in a relationship, and then what you want. Okay, so we will proceed on it, and much awaited, that is the flux of the electric field through the sphere, through the actual spherical coordinate system, that we will see. There is no much gain we saw calculating the flux through xyz or through a spherical coordinate system, because it is hybrid model we have used. Pure spherical coordinate system, that we will see. Okay, it is little bit time consuming. So that we will see, divergence we will see, and then we will find out. Okay, please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.